Hi, my name's Tim. I'm going to be going over a modeling technique that I used to create a 3D printed part that has threads on it so I can integrate something I'm designing with an existing part. Um, I'll put one caveat at the beginning to say that this is not the method I would recommend, simply because I think you can get much better results by using a traditional technique of using like a tap and die set. So if you're looking for a really accurate connection, a very good, strong connection, what I would recommend is designing your 3D model so that it has the proper hole size, which you can easily find online for whatever size thread, and then using the dies and taps to cut the threads. Um, and my understanding is that they actually have some that work particularly well with plastic. However, if you absolutely do have to do this, I've successfully created a 3D part that I've printed. And this is not the model that I'm doing, but it does demonstrate what I'm trying to do. Is I have this existing piece, and it has, I've got a bolt that goes onto it. And the first thing I did was I measured this. It's got a diameter of 3/8 of an inch, and this is 7/8 of an inch long, and there's 21 threads, which means this is a 3/8 24 screw thread type. So it's 24 threads per inch, and 3/8 inch diameter. So what I needed to do was I wanted to create the same thing so I can integrate with my model. Um, and since I have both of these, it actually makes it really easy to test the final product and see how it came out. Um, and so what I did was I created two things. I created a simple nut. So this nut is not as good and much more expensive, simply because I printed it in PLA instead of just buying one at the store for a lot less. But it was good. It's a good experience to see how well this technique works, and when you would want to use it and when you wouldn't. So basically, the only time I'd recommend doing this is if you have large threads that are easy to model, because you need to keep in mind the accuracy of your printer, and how good can it reproduce the threads. And what I found was that my printer actually, uh, the scale seems to be a little bit off. And what I would need to do is I would need to scale this up, because whenever I go to connect these two, it's a very close fit, but not quite. And what I could, potentially do at this point is get the thread started and kind of force it. But then I'd be doing the exact same thing as if I used a traditional type, drilling and then tap and die set, to do it, which would be the preferred way. So this one did not work out particularly well. However, since my scale on my printer seems to be off by a little on the small side, I do get a fairly decent connection here. Now, once I've got this screwed all the way in, I do have a little bit of play, a little bit of axial play, really. Um, I'm sorry, radial play, but axially it seems to be a decent connection. And I suppose at that point I've got it all the way, I've got the threads fully engaged. So it works, but if it's anything too important that you want to get a better connection, if you're going to do this, it will take a few iterations, because I know that my model is accurate. The issue is the ability to reproduce the model. And if you have a higher quality printer, you may be able to get a better result. But my expectation is, these differences are less than a millimeter. So I think you would really need to run a few test prints and then calibrate and see what kind of scaling factors do you need for the part that you're making. So without further ado, I use Blender for my modeling, and then I took some schematics from the web and used those to figure out exactly what I needed to do to create the model. So, and I modeled both the internal and external threads. So I've got the screw and the nut, and you can just follow along, and hopefully this will prove useful for somebody. So the first thing I had to do was to look up the standard screw profile. One of the nice things is that again, this is a standard. It's universally used, and for these screws you can actually do a little bit of math, and you can basically simplify this for the modeling to just two parameters: the major diameter and the pitch. So the major diameter being the outside of the screw, and the pitch being the distance from one thread to the next. And these values are actually quite easy to find if you just search around on the internet. So I took the model and I simplified it, and these 4 values that I show on here are what I need to model it in Blender using the technique that I'm using. Obviously, there's many ways to do it. This is just the way I did it. And to keep it simple, I'm going to show on here the values that I calculated. And obviously, whenever you're doing this for the threads you're concerned about, you'll need to do the same calculations. But it should be pretty straightforward. So we'll just go ahead and. All right, so I'm just going to delete these things. Don't need those. X delete, and tab over at edit mode. And basically, I'm going to subdivide this. This is just W subdivide. And my goal is I'm going to get rid of almost all of these vertices except for 2. So I just use C, select the ones I'm interested in, X delete. Oh, I need to not limit it to the visible. Okay, so switch over to the front view, and again, I just need these 2 vertices over on the side. So X delete. Now, I'm going to take that, and I'm going to go ahead and move it over to the right, and subdivide it. That gives me that little one in the middle. I move them up to 0.5, just put them at the 0, and then I can move them back down by 0.1323. Take the bottom one, and it needs to go down by 0.0583. So select this bottom vertex and the one above it, W subdivide, and now I can just take this guy and just go ahead and hit G, X, minus, let's see, 0.08, 0.8, okay, sorry. And then press A twice, select all, and here you go and hit the screw. So since the center is already, since I'm already at the center, I can just go ahead and pop this up to however many threads you want. I want to make this 1 inch long, so it's 24 threads. And if I change the, sorry, hold on, let me just get rid of the grid display. I find it a little distracting right now. Okay, so so this is my screw. It's looking okay, a little blocky, but okay. Now an interesting thing is, if you look, think about how this would screw down. And what we have by default here is a left-handed screw. Okay, so change this axis to -1, and now if you just look at it and think about how it would twist down into something, this is now a right-handed screw. Okay, so by changing the this value here, I can basically have a nice smooth curve. And for my final product, I used a value of 32. It gave me a very nice result. But to keep it simple and to make this demo go a little faster, I'm just going to leave this as 8. So it'll stay a little blocky, but you should get a pretty good idea of how to do it. And I don't think anyone wants to sit here and watch me clicking around the screen forever. So then I'm going to add a circle, and the radius of the circle is going to be the same. Okay. Now it's important that you notice that this point here, I actually have 2 points that are exactly overlapping. And if I just go ahead and start adding in the faces that I was going to do, we might have a problem in disconnected faces, which matters a great deal for your slicing program. Okay. Now, if I do not remove doubles, there's also a set of doubles at every one of these vertices where one turn went completely around. And you can see the difference here when I remove the doubles is that now all of those lines get highlighted instead of just 1 or 2. Okay, so now that I've removed doubles, I'm basically going to go switch over into Edge Select, and I'm just going to go around the top edge here and select all the faces. Now, when I'm doing this, I use the major diameter, which is fine because this is not the side that it's going to have. This is the side that will like go to the nut, to the hex end or whatever you want to put at the end. This is not the side that will be going down into the nut. That side I cannot use the major diameter, otherwise it will not work. All right. So go ahead and select this edge, subdivide it a couple times. That'll give me 4 little segments. Or I'm sorry, subdivide it and then select one of them and subdivide, and so I have 3 segments, and that just gives me 3 nice little edges, so I can connect these faces here. It's important. What I'm trying to do is I'm trying to have a nice closed geometry, so when I use my slicing program, it doesn't run into any errors. Okay, so that gives me the top. All right, and at this point, you might connect this to your model. And for what I'm going to do is I'm just going to put a I'm just going to take this extrude it, hit escape, scale it out to about scale factor 4, gives me a larger surface, hit E, extrude, and I can just hit Z, and go up by 5 millimeters. And then Alt F will close that top face for me. All right. So now I need to work at the other end. Now on this side, it's very important that I use a smaller radius for the circle that I'm going to add. Okay, and the reason is because if I use the major diameter, then I'm going to have an area that I will not be able to engage the threads whenever I go into the screw, because that's kind of how the screw works. Okay, so I'm going to select this very bottom vertex. Okay, and I'm going to move my I'm going to center on that, so that whenever so what I do is I just press Shift S, and so that whenever I'm inserting, I can now get the Z value of that very bottom vertex. Just makes it a little simpler, and it's not super important. As long as you're kind of below that that point, you should be fine. Again, I'm going to go to a smaller diameter on the smaller radius here, and go ahead and insert that. And I'm just going to use the exact same thing. I'm going to go into Edge Select and just connect these faces. So when I'm doing this, I'm just pressing F between each face, and that works pretty easily. Just bear with me for a second. And again, there may be faster ways to do some of these techniques, but I'm trying to keep this as simple as possible. So on this side, we have 4 edges, if you look. Okay, so, oops, didn't mean to do that. You can Control C to undo. I want to select just this edge, W, subdivide again. Now I've got 4 parts. Now I'm selecting each of these, all 3 of these edges, just because sometimes if you select the 2 opposite sides, and this geometry is changing a lot, sometimes it will flip. The part will have a twist, or that face will have a twist in it. It didn't happen this time, but sometimes it does happen. So to prevent that from happening, I just select each of the 3 edges that I want to make the face out of, and then I just bring the bottom point down. Gives me a nice tip, just a little extra help in on getting the screw started. Now, just press A twice, so I can select the whole model, and all I'm doing is I want to rotate this bad boy up 180 degrees so that I am at the right orientation for printing the part. And there we go. Now for your internal thread, similarly you need different values, but also easy to calculate, and these are the 4 values that you'll need to calculate. Okay, so back into Blender. Again, just starting fresh, delete these objects, go into edit mode. This is going to be a very similar technique, okay? Just subdivide. Again, I want to get rid of all those vertices. Obviously there are other ways to do this. This is just a way I find to be quite simple. All right, delete them, go to the front, and there we go. Delete the vertices. Okay, so now I'm going to go ahead and move over and subdivide. Take that center one out. I go up by 0.5, puts it at 0, and then go down. And select the bottom vertex. Okay, sorry. I have multiple things going on the other monitor. Okay, select the bottom vertex and bring it down just a little bit. Go ahead and select both of these, W, subdivide, and now this center part needs to move out. Okay, so all right, select everything and go ahead and do the screw. Go ahead and select how long you want to make it. I'm making it 1/2 inch, so it's going to be 12 turns. And then look at the number of points you want. This time I did 10, and again change this Z value to -1 so I can get a right-handed screw, or right-handed nut. Just turn this grid floor off again. Okay. So look, that's left-handed, and now we're back to right-handed. Okay, not bad. So the rest of the process is basically the same. The values that we have to use are a little bit different. Whenever I'm inserting this, now it's important that this is a larger radius, and actually, if you make it a little bit larger than the major radius, that will actually help a little bit. So to keep it simple, just radius of 5 here, and since I did 10 points instead of 8, I need a little bit of a rotation just to get these things straight. Actually isn't that important, but it does make for a nicer view, easier to follow. Okay, so I'm going to go into edge select and basically just connect all of these edges one at a time. So when you're doing this, it's useful to limit selection to visible for this part. All right, go ahead and divide that twice because there's 4 edges I need to connect. Let's see if it twists any of the parts here if I just do the opposite edges. Oh, you see, that's what I'm talking about right there. That part is twisted around. So Control Z, undo, and just select all of the neighboring edges, and just zoom in to make sure I get all 4 edges. Bam. So no twisted part. Very nice. Okay. Now I'm going to take the top row here. Okay. And there we go. So all I did was extrude, scale it out. And you know what? Actually, I think I want to put a hex nut on this. So instead, I'm just going to make sure the cursor's at the center, and I'm going to add a circle. And to make a hex nut, all I do is I put in 6 vertices, and the radius. So if I want a 20 millimeter socket to work on this, I just divide 20 millimeters by square root of 3, and that will give me 11.547 millimeters. So I'm assuming that I'm using millimeters for this. And now I have a hex that will work with a 20 millimeter socket. And just go and select these all. And Alt F will connect the faces nicely. Perfect. And now I have my top edge. Okay. At this point, you can probably stop watching because I'm just going to do the exact same thing to the bottom. I'm going to select the bottom vertex, and then I'm going to add, and that gives me the ability to add it at that bottom height, but I'll change X and Y to 0. Okay, sorry. All right. So, okay, sorry, I put in the outer ring first, and now the inner ring that I'm going to use to connect. Again, this one is at 10 vertices and radius at 5, and now I can go in and do the exact same edge select, and I've already got the hex outside. I know it's a little bit tedious at this point. Just simplify it twice. Go ahead and, oops. There we go. Oh, see, it's twisted, so I've got to make sure I get all 3 sides so that it doesn't twist. And this last one, I'll just get all 4. Bam. And now just need to go in and select the outer edge here. Okay, outer edge. You can tell I'm not trying to prove that I'm better at Blender than I actually am. I'm showing all my mistakes. Okay, and again, Alt-F to close those faces. And last but not least, the 6 edges for, oops, escape. Okay. And just go ahead and close this up. And that is it. So that's it. It's like I said, it's not too difficult. Some of the details are a bit tedious, and some of the math is maybe annoying. But I believe that if you just follow the steps I took, you can also create one of these. And the next thing you would need to do is print one of these. I would recommend printing just a small section of the thread that you're working with, seeing how well it fits, and then maybe bump it up by 5% or down by 5% as necessary, for your printer. Because then there's also material shrinkage. So you need to keep in mind what type of material you're working with, and do you have an experience, with it? Does it shrink during the cooling process, and by what extent? So probably the simplest is just create a few test prints, and then you can go going from there. I hope you found this useful. I found it very instructive, and it works. So good luck.